In this video, I'm going to show you how to solve an exponential equation when you can use common bases to do so. So in order to be able to use a common base to solve an exponential equation, you would have to first check to see if you could rewrite your base or rewrite your value as a base raised to an exponent. So I have some very common ones written off to the side in purple here. You could make these lists longer. You could also just like keep putting numbers, like I know 6 squared is 36. And then if I do times 6 again, then I could write down 6 to the third is 216 and so on. But really, it's just a guess and check game here. Another important exponent fact that you need to know is what happens when you have a negative exponent. So if I was going to do 2 to the negative 2 instead of 2 to the positive 2, this is now 1 over 4. 2 to the negative 3 is now 1 over 8. So if you see here, 2 squared is positive 4. 2 to the negative 2 is 1 over 4. 2 to the third was 8. 2 to the negative third is 1 over 8. And so knowing those exponent rules is also very valuable when solving these problems. All right, so let's just hop right in. So I have 4 to the x minus 4 is equal to 16. So if I look at my list, I can see that I could rewrite 2 to the fourth as 16. I could write 4 squared as 16. Well, since I already have a base of 4 here, if I change the 16 to be base of 4, using that fact right there, then I can solve. So I'm going to do 4 to the x minus 4 is equal to 4 squared. And so I have 4 to the x minus 4 is equal to 4 squared. And so I'm going to drop the 4's and write this as x minus 4 is equal to 2. I can drop the bases, because if the bases are the same, then the exponents have to be the same. So if it's going to be equal, right? If it's going to be an equation, they're equal to each other. And so then I would have x is equal to 6. So I just added the 4 to both sides, and voila. All right, so I'm going to do number 2 now. I'm looking at my base 2. I want to see if there's a way I could rewrite 8 with a base 2, and there is right here. And so I'm going to rewrite this problem as 2 to the 3x is equal to, 2 to the third. Now, once I have the same base, I drop the bases, set the exponents equal to each other. 3x is equal to 3. Divide by 3 on both sides, and x is 1. All right, a little bit harder when we get to number 3 here. I have 2 to the something is 1 over 4. Well, remember, negative exponents do this. So if I change 1 over 4 to be 2 to the negative 2, I have 2 to the x is equal to 2 to the negative 2. That's how I can rewrite 1/4. And so then I drop the bases, and I keep moving the screen. X is negative 2. All right, number 4. I have 3 to the x is 1 over 27. Well, I already know there's going to be a negative exponent involved here. I'm going to think about 3 to the what is 27. 3 to the third is 27. So that would mean that I could rewrite 3 to the x is equal to 3 to the negative third. So if 3 to the positive third is 27, then 3 to the negative third is 1 over 27. And then I drop the bases, and my exponent's negative 3. All right, number 5. I have 1/4, and so I know 4 to the negative 1 is 1/4. And again, my bases are now the same. Drop them, and x is negative 1. All right, let's take this up a notch. So if I look at number 6 here, I have both our base 3. Well, I didn't really take it up a notch. They're already the same base. Just drop them and set your exponents equal to each other. Because if the bases are the same, the exponents have to be the same. So I'm going to add 1, 6 is equal to 2x, divide by 2, and x is 3. All right, number 7 is actually taking it up a notch. All right, I've got a 9 and a 27. So I'm going to go to my list, because I just like, check out my list here. I see a 9 right here, and I see a 27 right there. And that's the only place I see them. So I know 3 squared is 9 and 3 cubed is 27. And again, this is something you could guess and check in your calculator. So I'm going to do 3 squared is the same thing as 9, and I'm going to raise it to the 4x. I have 3 to the third is really 27, and I'm going to raise it to the x minus 2. So I've rewritten my bases. I haven't done anything wrong. I have kept things equivalent. And so I can drop my bases, but I have to use the power to a power rule, which is to multiply. So I'm really doing 2 times 4x is equal to 3 times x minus 2. So I'm dropping these bases, but I'm not dropping their powers. Instead, I'm distributing their powers. So I have 2 times 4x is 8x, and then I'm going to distribute my 3. I'm going to take away 3x. That leaves me with 5x is equal to negative 6. Divide by 5. And x is negative 6/5. All right, number 8. I see 1 over 25. Well, I know 5 squared is 25, so I could rewrite this as 5 to the negative 2. And now I have a base of 5 for both, so I can drop my bases, do negative 2 times 2x is equal to x minus 5. So once I get that same base, I drop them. Simplify, that's negative 4x. Whoopsies. I would take away x from both sides. I have negative 5x equals negative 5, so x would have to be 1. All right, 2 more. 81. When I see 81, I think 9 squared. So I'm going to think, okay, can I raise 9 to something to get 27? And I can't. So when I see 27, I think 3 to the 3rd. And so I'm going to just guess and check and see 3 to the 4th in my calculator. Well, that's 81. All right, the 3's, the bases are the same. Drop them. I have 4 is equal to 3 times x minus 1. I treat this like I'm distributing the 3 because it's the power to a power rule for exponents. So this leaves me with 4 is equal to 3x minus 3, take away my, whoopsies, add my 3, I'm going a little too quick, and I have 7 is equal to 3x, divide by that 3, and x is 7 over 3. All right, number 10. We have a 64 and a 16. I know 4 squared is 16. I also know 4 to the 3rd is 64, but you could guess and check using your calculator. So I'm going to rewrite this as 4 to the 3rd. I'm going to rewrite this as 4 squared. I can drop these bases. 3 is 2 times 2x. I'm just multiplying because it's power to a power. 2 times 2x is 4x. Divide by 4. And x is 3/4, or you could say 0.75. Same thing.